Welcome to Math with Michelle, where math finally makes sense. Whether you're tackling high school math or diving into college algebra, I'm here to break it down step by step with real examples and zero stress. From algebra to functions, graphs to equations, I've got it covered. Hit that like button and let's master math together. Welcome to volume of prisms and cylinders. Now, before we get started, I want to make sure that you understand volume is like a 3D thing. It's like how much air is filling up your room. So when we talk about volume, you can think about it sometimes as like if you've seen sugar cubes in the store, you see these little bitty cubes. And so the volume is wanting to know how many cubes could fill up the room. So you can think of that reason why volume is labeled in centimeters cubed, meters cubed. What they're saying is if you see 8 centimeters cubed, they're saying here's a cube. It's 1 centimeter by 1 centimeter by 1 centimeter, and you would need 8 of them to make that shape. Okay, so volume is 3D, so hence why your label is a 3 on it as well. So when we did area, let's say you're doing the area of the rectangle, here we were only counting quote unquote squares, right? So you were just counting how many squares are in there. Let's say it was 5 inches by 2 inches. Well, 3 inches, we'll go 3. Because that's what I drew. 5 inches by 3 inches, so we'd have 15 squares, or 15 square inches. And that's how that's actually said as square inches. Some people say it inches squared, but basically we're saying 15 tiles. It would take 15 tiles. Now, let's take that same shape, that's 5 by 3, and now let's give it some depth. Let's make 2 rows of it. Okay? So we had there's 2, 3, 4, 5, 2, 3. But now, instead of just the 1 row, we have 2 layers, right? And of course, they're all going back. So, since we double stacked it, we took the 15 squares and we double stacked it. Now we have 30 cubic inches. So how could I do this without physically counting squares? Well, here we did length times width. And that got us the area of that base. And then we said, well, there's 2 levels. So we took the area of the base, which was 15, and we multiplied it by the number of levels, or the height. Okay, so does that always work? And in the case of anything with parallel faces, i.e. prisms and cylinders, that's exactly right. Volume equals, and you'll see this written like this on your formula sheet if you're in Missouri, capital BH. The capital B right there stands for area of the base, where H stands to the height, or the distance between the parallel bases. Okay, so what does that really mean? Well, let's say you're sleeping in a tent. Might be one of my better tents. Okay. Now, you know your tent is a triangular prism because it has a triangle face here and a triangle face back here. Those are our parallel bases, the 2 triangles. Okay. You know that you actually barely fit in it. You had to duck a smidge, and it's 6 foot tall and 8 foot wide, but it is 12 foot long. meaning 12 foot from front to back. So we have a triangle for the face. So how do I find the area of a triangle? Because we need to take the area of the triangle, because that's what kind it is, multiplied by the height. And that would be the height between triangles. So there's 12 foot between the two triangles. Okay. And I really clarify that height because I understand that a lot of times when we talk about length, area of the rectangle, we say length times width, or we say base times height. When we talk about area of a triangle, we say 1/2 base times height. So we have to understand, do we mean the triangle height or do we mean the prism height? And this here is the prism height, okay? So the area of the triangle is 1/2 base times height. Okay, now I can get my volume. We're just going to go ahead and type that into a calculator. Okay. If you don't want to type 1/2, you can always type 0.5 times 8 times 6 times 12. And we get 288 cubic feet. So if you're trying to find an air conditioner to cool your tent, you would need to make sure it could handle 288 cubic feet. Now for those of you who are like, I ain't ever going to use this, hey, a fun little side note is, I'm sure if you're in, I've been around nurses or medicine, you've heard of 1 cc. cc stands for cubic centimeter. And it just happens to be equal to 1 milliliter. So, fun fact. So, does this work for cylinders? Well, let's see if once we look at the formula, you don't remember it. So here's a circular. So a cylinder would also be a circular prism. So we need the area of the circle multiplied by the height of the prism. And I'm just going to label this R and this H. So how do I find the area of a circle? Well, pi r squared. And the height is labeled H. So the volume would equal pi r squared H. Absolutely, that formula has been there before. So, okay, let's try another one. Okay. Rectangular prism. Let's look at the word. Rectangular . So the volume we need to know, we need to multiply it by the prism height. And the formula for a rectangle is length times width. Oh, yep. Volume is length times width times height. We've memorized so many different formulas without realizing that we could have just memorized one. Now, cueing the I'm not the best artist in the world, so I need to make sure we understand something moving forward. This is a traditional rectangular prism. It looks like a box. This is also a rectangular, or this is an oblique prism. It's no longer rectangular. But we find the area and the volume the same way. We still have to do the base times the height. Remember, height has to happen at a 90-degree angle, or length times width, right? And then we're going to times by that height, which is the distance between the two parallel faces. So make sure that you think, like, this would be like a deck of cards perfectly stacked up, and then you know how you can kind of just take them and go and shift them? That's kind of the shape you get there. Okay? So a fun thing, we have Cavalieri, and he has this principle. Okay. He says that if you have two 3D shapes, okay, they have the same height and they have the same cross-sectional area, then they will have the same volume. Well, it makes sense. A cross-sectional area would be the base, and the area of the base times the height is the volume. So it makes sense if we have two 3D shapes with the same cross-sectional area and the same height, they'll get the same volume. They don't necessarily have to be the same shape. It's just that the area of their base needs to be the same. What could that mean? Okay, well, let's go ahead and let's look at a triangular prism. So the triangle would be the cross section, right? Versus a rectangular prism. Okay, now they're both going to have the same height between their faces. We're going to make these both 4. We'll call it inches. Okay. This is going to be 5 inches wide and 1 inch tall, right? And this will be 5 inches tall and 2 inches wide. Okay. So here we'd have the area of the triangle times the prism height versus area of the rectangle times the prism height. Now, in both cases, our prism height is 4. Okay, and the area of the rectangle, 5 by 1, is 5. This has a volume of 20. Over here, 1/2 base times height. So 5 times 2 is 10, times 1/2 is 5. So 5 times 4, also 20. So they had the same cross-sectional area and the same prism height, and therefore they came up with the same volume. Were they the same shapes? No, but they did have the same volume. So that's what Cavalier is saying, is that if you have that phenomenon, that it can happen. You don't have to have exactly the same shapes to have the same volume. Okay. So let's look at some hypotheticals. Okay. You have a swimming pool. Okay. Your swimming pool is 30 foot by 20 foot by 4 foot. And it's a rectangular prism. It's just a basic rectangular pool. There's no sloping. It's just a big vat of water. How many cubic feet of water do you have? What's the volume? So we'd have to do length times width, because that would be the area of the rectangle, times the height, or the depth in this case, because your pool is so many deep, right? And we find out that if you type that in, we have 2,400 cubic feet of water. Okay, let's say that pool wasn't big enough for you. Let's say you wanted to triple the sides but keep the depth the same. I.e. length and width. Okay, so now instead of 30 foot long, it's 90 foot long. Instead of 20 foot wide, it's 60 foot wide, but now it's 4 feet deep. Now you need 21,600 cubic feet of water. That changed. We only tripled the sides, but that is 9 times as much water. Why? Well, because we had the length times the width times the height, or in our case, depth. And we tripled the length and we tripled the width. Oh, do you see that blue times 9 coming in there? Because 3 times 3 is 9. Yeah. Had we tripled all 3 of them, the length, the width, and the height, then it would have been 27 times as much water. So every time you change one dimension, it drastically changes how much water you're going to need. Now, switch this up. Think about like concrete for a patio. I mean, you're probably not going to change the depth, but if you just double the length and width of your patio that you're pouring, you need 4 times as much concrete. Why? Well, let's say you're going to just build this patio right here. And it wasn't going to be very deep. But then you decide, hey, I want to double the length and double the width. Yep. Whereas once you were just pouring 1 patio, now it's like you're pouring 4. So that's what's going on when we're doing these extra dimensions. And I see the changing of units to be a problem when this idea comes in as well. So let's look at a cubic yard. And a lot of times when you order rock, you get a cubic yard. What a cubic yard is, and cubes are actually my best shape to draw. I've had to draw them so much that it's the one thing I can do okay at. Okay, so we have our cubic yard sitting here. A cubic yard would be 1 yard by 1 yard by 1 yard. How many cubic feet is that? Well, let's think. One yard is 3 foot by 3 foot by 3 foot, and length times width times height, or the area of the base, which is 9, times the height, is 27 cubic feet. How many cubic inches is that? Well, it would be 36 inches by 36 inches by 36 inches, right? Or 46,656 cubic inches. So when you're ordering material, if you've done your measurement in feet and they're asking you to buy by the cubic yard, we have to be careful with our conversion. So if you're working in geometry, I suggest you convert it at the side length, not afterwards. Especially if maybe they've labeled one side in feet and one side in inches. You don't want to work with random labels. You want to keep everything in one consistent label. So when you're doing these formulas, check your label first. Now, one last one that we're going to do, and that's going to be to find this following volume. Not my best picture. We have a slanted cylinder. It's an oblique prism. So when you have an oblique prism, your height must come in perpendicular to your base. It has to. So if this is, I'll do the, I can't draw, right? I've kind of noticed that today, is I can't draw. Not my best skill. I like my math, but not so much my drawing. Here we go. So when you have a oblique cylinder, make sure that this 7 centimeters right here, that's how much it's slanted. That's not the true height. So we have a circle for the base. So the area of that would be pi times our radius squared. Then we multiply it by the space between the two circles. 7 centimeters is not the shortest distance between the two circles. 6 centimeters is. So we would have 25 times 6, or 150 pi centimeters cubed, or cubic centimeters. So make sure you're getting the true height between the two faces, not any cross-tracking across the wherever. The smallest number between the two faces is what you want for your height. And if you can remember that, area of the base times the height gets you your volume. You don't need the formula sheet. You've got this.
Thanks for learning with me here on Math with Michelle. If this helped, give it a like and don't forget to subscribe for more clear and simple math lessons. Got a question or topic you want me to cover? And drop it in the comments. Until next time, keep practicing, stay curious, and remember, you've got this.